Imagine architects who don't use blueprints or bricks but mud, silk, and saliva, creations that can last centuries and reshape entire landscapes. These are nature's architects, whose instinctive engineering rivals our own. Today, we'll uncover the secrets behind animal-built dams, mounds, and nests. Masterpieces perfected over millions of years. Prepare to be amazed by the world of nature's engineers. In North America and Eurasia, the beaver transforms rivers with its engineering genius. Driven to create a safe pond, the beaver fells trees with powerful incisors, dragging logs to a chosen spot in the stream. Large logs form the dam's foundation, placed parallel to the current for strength. The beaver instinctively selects narrow points in the stream, minimizing effort. Smaller branches are woven between logs, then sealed with mud, stones, and aquatic plants. The sound of trickling water signals leaks. Beavers patch relentlessly day and night. A family can build dams hundreds of feet long, creating vast wetlands. At the pond's center, they build a dome-shaped lodge of sticks and mud, with underwater entrances for safety. Inside, a drying platform leads to a dry, insulated living chamber, ventilated by a hidden hole at the top. These structures protect the family and provide a secure nursery for their young. But the beaver's impact goes further. The dam creates a rich, wetland ecosystem. Fish, amphibians, insects, and waterfowl thrive in the new habitat. Moose and deer feed on lush aquatic plants. The beaver is a keystone species. Its construction supports countless other lives. Generations maintain and expand the same dam, some lasting over a century. These living monuments reshape landscapes, creating legacies in water and wood. The beaver's drive to build is a force that transforms entire ecosystems. Their work is a testament to the power of instinctive engineering. The beaver doesn't just build a home, it builds a world for others. Nature's engineers indeed. The legacy of the beaver is written in every thriving wetland. Across the world's savannas, towering termite mounds rise, living skyscrapers built by millions of tiny insects. These mounds are marvels of climate control, maintaining stable conditions for the colony's fungus gardens. A central chimney and a network of surface channels create a passive ventilation system, circulating air and regulating temperature. Termites use soil, saliva, and feces to build rock-hard walls, thick for defense, porous for gas exchange. Deep underground, nurseries, fungus gardens, and the queen's chamber form the colony's heart. The queen, laying thousands of eggs daily, is protected by the entire structure. The mound's scale is staggering. If humans built proportionally, it would be over a mile high. Blind workers, guided by chemical signals, collaborate to build, repair, and expand their fortress. The mound breathes, self-regulates, and shelters millions. A living building powered by collective instinct. Human architects strive to replicate this natural efficiency in green buildings. The termite mound is a testament to evolution's ingenuity. It's a skyscraper of earth and saliva, a monument to teamwork. Each mound is a living, breathing city. The colony's survival depends on this architectural masterpiece. Nature's skyscrapers stand as proof of what collective effort can achieve. The termite mound is a marvel of natural engineering. In Africa and Asia, the weaverbird's nest is a marvel of avian craftsmanship. The male weaverbird builds to impress, a nest so intricate only the best will attract a mate. Using just his beak and feet, he knots and weaves hundreds of grass strands, anchoring the nest to a drooping branch. The process is a race against time and a test of skill. Each strand is carefully selected and woven. Designs vary. Some nests are simple spheres, others have long entrance tunnels to deter predators. In social species, trees become bustling colonies, festooned with dozens of nests. The female inspects each nest, testing its strength and craftsmanship. If it fails her standards, the male must start over. Only the best builders succeed. This rigorous selection drives the evolution of nest-building skill. The nest is lightweight yet strong, able to withstand wind and rain. It's a physical display of the male's fitness and dedication. The weaverbird's nest is more than a home. It's a woven wonder. Patience and precision turn simple grass into a masterpiece. The art of the knot is perfected in every nest. The weaverbird's legacy hangs from every branch. Nature's artisans, one strand at a time. Inside a beehive, tens of thousands of honeybees build one of nature's most perfect structures, the honeycomb. Worker bees secrete wax, shaping it into interlocking hexagonal cells. The hexagon is mathematically ideal, using minimal material, leaving no wasted space. Each cell is angled slightly upward to keep honey from dripping out. The honeycomb stores food, raises young, and supports the hive's weight. Bees work on both sides of the comb, each building its own cell, yet the structure is seamless. The walls are thin but incredibly strong. A pound of comb can hold several pounds of honey. The hive is organized. Central combs for brood, outer combs for honey and pollen. Division of labor is precise. Young bees build, older bees forage, guards protect. Pheromones from the queen coordinate the colony's efforts. The honeycomb is a triumph of swarm intelligence. No single architect, just simple rules followed by thousands. The result is a structure of stunning efficiency and beauty. The hive functions as a superorganism, each bee a vital part. The honeycomb is a model of natural engineering. It's a reminder that collective wisdom can create perfection, nature's geometry built in wax. Beneath tropical seas, coral reefs rise, vast cities built by tiny coral polyps. Each polyp secretes a limestone skeleton, joining with millions of others to form the reef. Over centuries, these skeletons accumulate, creating massive underwater structures. The secret to their success is partnership. Microscopic algae live inside the polyps, providing energy through photosynthesis. This symbiosis powers rapid reef growth and gives corals their vibrant colors. The reef's complex architecture shelters a quarter of all marine life, fish, crustaceans, and more. Coral reefs buffer coastlines from storms and erosion, acting as natural breakwaters. They are the rainforests of the sea, hotspots of biodiversity. Yet reefs are fragile. Warming oceans disrupt the coral-algae partnership, causing bleaching and death. When corals die, the city crumbles and marine life vanishes. The health of reefs reflects the health of our oceans. Coral polyps, though tiny, are master builders shaping entire ecosystems. Their ancient collaboration sustains life beneath the waves. The reef is a living monument to partnership and persistence. Nature's greatest city is built by the smallest hands. The coral reef is a wonder of collective creation. Paper wasps are nature's paper makers, building delicate nests from chewed wood and saliva. A lone queen starts the process, scraping wood fibers and mixing them into a strong, lightweight pulp. She builds a stalk, then hexagonal cells, laying eggs in each. Her first brood becomes workers, taking over foraging, feeding, and nest expansion. The nest grows as layers of cells are added, forming an open-faced comb. This design is efficient, lightweight, well-ventilated, and easy to monitor. Wasps regulate nest temperature by spreading water droplets, cooling the brood through evaporation. The exposed nest demands constant defense. Wasps are vigilant, their stings a potent deterrent. Social cooperation is key. Many eyes and stingers protect the colony. The nest's paper walls insulate and shelter the developing young. Each nest is a masterpiece of natural engineering, suspended in the open air. The wasp's paper-making predates human invention by millennia. Their homes are both fortress and nursery. The colony thrives through teamwork and innovation. The paper wasp's nest is a triumph of instinct and adaptation. Nature's architects building with pulp and purpose. In the morning dew, a spider's orb web glistens, a masterpiece of silk and geometry. The spider spins alone, using touch and instinct to create its deadly trap. Spider silk is stronger than steel, more elastic than nylon, and tailored for each part of the web. Construction begins with a bridge line, then a frame and radial spokes, each perfectly spaced. The spider's body is its measuring tool, ensuring geometric precision. Once the framework is set, the spider spins a sticky spiral, designed to capture prey. The web's structure transmits vibrations, alerting the spider to every movement. The sticky spiral stretches to entangle insects, while strong spokes hold the web together. Some spiders add zigzag patterns, stabilimenta, for camouflage or to attract prey. Webs are rebuilt daily. Old silk is recycled for efficiency. Each web is a new feat of engineering, balancing strength and delicacy. The spider's work is both art and survival strategy. Evolution has honed this process to perfection. The orb web is a testament to nature's problem-solving. Every strand is placed with purpose. The spider's web is a symbol of ingenuity and adaptation. From beaver dams to spider webs, the drive to build is a universal force in nature. These animal architects solve life's challenges with instinctive brilliance, creating homes that are masterpieces of engineering. Their structures are legacies of survival, innovation, and adaptation. Next time you see a simple web or nest, remember the artistry and evolution behind it. In every humble structure, we glimpse the universal urge to shape the world and build a home.